All right. Hello, everyone. Welcome. Hope everyone's doing well today. Hope everybody had a great weekend. Let's talk about some schedule logistical stuff first before we talk about some code for today. I'm sure you're probably all wondering about the exam that you took last week. The exams are almost done being graded. I'm in the tying up loose ends phase of grading the exams. It's possible the grades will be out later today still. I think tomorrow is probably more likely in terms of when you're going to see your exam grades back. It won't be any later than that. So tomorrow at the latest is when you'll have your exam grades back. I'll make a post on Piazza when the exam grades have been finished and posted. You'll also have a chance to submit regrade requests if you think something hasn't been graded properly on the exam. All of that information will be posted and as soon as the exam grades are posted. And then as far as the schedule goes for this week, because we just had an exam last week, kind of get to take a little breath this week. This is a bit more of a chill week than last week, certainly, in this class. And there's no assignment due this week, right? The assignment's not due until next week. We do have another studio this week, which is, I think, one of the consistently top-rated studios of the entire semester. It's really fun. The TAs love it. Students usually love it. So kind of a chill week. The course materials also maybe not quite as conceptually difficult as perhaps arrays were, although, spoiler alert, we're probably going to see some arrays today. Anyway, does anybody have any questions about the schedule or anything like that before we hop in and do some coding today? We all good as far as expectations and schedule and stuff? All right, great. Then I'm going to honestly try and do something a little bit different today compared to how I've run past lectures. There's, well, actually, for starters, let me back up for a second and show you that because we took the first exam last week, right? We finished all of the units in the first unit of exercises. So the first exercises repository has modules 1, 2, and 3. That's what we just took the exam over. We're starting a new chunk of 3 today. So that means that I am not using this exercises 1 repo anymore. I have now moved on to the exercises 2 repository. If you need the exercises 2 repository, then head on over to Canvas and click on the link to grab yourself a copy of that repository if you haven't done so already. Hopefully you took a look at it before class. I really hope and somewhat expect you to take a look at these before class. Not necessarily be an expert on it, but at least familiarize yourself with this material a little bit before coming to class. And so I've already got this loaded up today in my Eclipse. You can see actually compared to some of the previous modules, there's just not as many examples. There's just not as much stuff we're covering, at least this week. However, you'll start to see that the programs are going to get bigger and more complicated and do more stuff than we have been doing so far, and that's pretty natural, right? If you think about the kinds of things we've been doing in this class compared to an app like Facebook or TikTok or something, there's a lot more going on in those apps than what we've been doing. So we are going to build up the complexity, do more and more things. What I would like to do this today, actually, I'm going to work on one example, I think, for the entire class, and that'll actually help me explain almost all the concepts, maybe not every single concept from today, but almost all of the concepts that were in the prep work for today. And the example that I'm going to be focusing on / working with is this one that has the moving ball. So this is one of the practice problems that I hope you took a look at before coming to class today. But the first thing I want to do is just kind of go over it with everyone, make sure we understand what's going on, how it works, and then maybe tweak a little bit, see if we can do some other stuff with this exercise. So first, let's just run it and look at it and see what happens. This is an example of an animation. So a big part of this week's topic was how do we draw stuff on the screen? How do we produce animations on the screen? This is a very simple animation. You can see it actually looks a little bit choppy. I may try and fix that in just a moment. But before we do that, let's just kind of recap some basics about what we're looking at here. This screen is called the canvas that we're looking at, and it has a coordinate system, right? Anybody remember, for example, what this coordinate is going to be down here in the left corner? probably exactly what you think it is from a coordinate perspective. We're gonna have 0, 0 down here in the bottom left. Up in the top right, that's gonna be 1, 1, 1 comma 1. And so right smack in the middle would be 0.5, 0.5. And I can consider that I can draw anything anywhere I want on the screen using that coordinate system, right? But how? How am I actually drawing what is currently a circle going across the screen? It's this line right here. And this is using what's called an API. That was sort of probably the main focus of this week's material. We're using an API called Standard Draw. It's actually not the first API that we've really seen or taken a look at in this class, but it's definitely one of the ones that we're going to be using a lot when it comes to animations. In fact, I would like to Google, if you Google Standard Draw, the first thing that's going to pop up is a page from Princeton University who developed this little library. And if I click on that link, I get a page that looks like this. This page is also linked from Canvas. I believe the prep work many times, or a similar page at least, is linked. So hopefully you saw this as you were going through the prep work for today. This is actually what I would call an API. So if somebody says, hey, what's the API? What they're really asking for is a list of all the things that this thing can do. So this is quite literally a list of everything that I can do with this Standard Draw library. So as you can imagine, it's going to be used to draw stuff. But there's actually a lot of other stuff you can do with it as well. I got to be honest with you, I've been teaching this class for years. I've used Standard Draw for years, and while I know how to do some of this stuff, I don't know all of this stuff. I don't know everything that Standard Draw can. I have not used everything, right? And I think that's very normal. I think that's entirely normal part of programming, right? Sometimes I just need to use some of what's available to me. Maybe I don't even know everything that's available to me. As programmers, it's our job to understand when we don't know something and then figure out how to learn it, how to do it, how to do that thing. So looking up the API is, referring to the documentation is good programming. You're going to run into plenty of situations where I want to do this thing, but I'm not quite sure how to do this thing. And that's your clue to start Googling, start looking up the API, start looking at the documentation. So for example, I saw that it was using this point, right? And so if I click on it, it'll actually take me down to a definition, and it says, draws a point centered at X and Y. So I know that these values X and Y in the parentheses here represent the center point of whatever's being drawn. And so, there's plenty of other methods available, such as a circle method, or I can draw filled or unfilled values, ellipses, and then actually eventually we'll see one, I think, called polygon, which can be used to draw any shape that we want, right? So I'm not limited in that regard. And so yeah, lots and lots and lots of different stuff. We can even import images. So this has been a fun thing for students to play with in the past. Import pictures into Standard Draw. There's lots and lots of stuff that we can do. As I mentioned before, this is not the first API that we've used. Actually, one of the other APIs that we've used before now would be Scanner. Oops, not that kind of scanner. Scanner in Java. Let's do that. Make sure that we're talking about Java and not like a flatbed scanner. When I'm referring to especially the Java stuff that it's provided to us from Java, I'm looking for the ones that are provided to us from Oracle. Oracle owns Java. Oracle is the company that makes Java, basically, and they publish the official APIs for Java. So if you want to know how to use Scanner, right, you Google Scanner in Java, here's one of the first pages that pops up, and notice that it shows me some examples on how I can create. We've done exactly this, right? Showed you this on the first day of class. So show you some examples on how to use it, and then down here you're going to see a list eventually of all the different things that you can do with scanners. So we'll see some things that we recognize in here, such as here we go, next int. We've used that before, right? Next double, or just next line, right? We've used those with the scanner before. You can see there's tons and tons of stuff that the scanner can also do. This is another situation where, do I know what every single one of these things does? No. I've used some of them before. Some of them I have never used before. I've been coding for, decades now. And I've never used some of this stuff, and that's okay, right? I know how to use the stuff that I need to know how to use, and if I don't know how to use something and I need to use it, then I'll go look it up and I'll figure out how to use it. That's what the APIs help me to do. So I'm trying to kind of build your confidence as programmers and give you the permission, even though you don't really need my permission, to look stuff up. If you don't know something, it's okay to Google it. It's okay to look it up. It's okay to ask other people. That's programming. I want to encourage that kind of collaborative environment in this class. But let's return to our little simple application here. It's moving a ball across the screen. So I'm not drawing just an image, right? I'm making something move. I'm doing animations. And so I want to play around with these animations a little bit, but before we can do that, I think it's very important to understand the 3 phases of the animation process. So all animations are going to take place in a loop. And within that loop, I'm going to repeat the same 3 things over and over again, the same 3 phases over and over again. Here's my loop. This looks like a little bit of a weird loop here. In past classes, I might have told you that this was not a good idea to write loops like this. This is an example of a loop that's going to run infinitely, but keep in mind that I can click the X up here to stop the program and exit the loop. So that kind of gives me a way to make sure that this loop actually will stop. But this is our main animation loop right here. And within this loop, we have 3 steps. Step 1, I'll number it, is clear the canvas. So in order to understand why I have to clear the canvas, it's important to understand a little bit how animations work. When you have an animation, you're drawing pictures, but you're doing it very quickly. So each picture that I draw as part of an animation is called a frame. And the way that we trick our brains into thinking it's an animation is by drawing lots of frames over and over and over again very fast. You've probably heard this referred to, especially if you play video games a lot. You've heard of frame rate or frames per second. That's what we're talking about here. You know, the bare minimum standard is usually around 30 frames per second if you're trying to get smooth animation. But the more frames you can draw per second, the smoother the animation is going to be. So, you know, people with heavy-duty graphics cards are shooting for 60 frames per second or even more, right, if they can, to get the smooth animation that they want. But in order to draw the next frame, the first thing that I have to do is get rid of the last frame, right? So here I am removing the previous frame from the screen, and I'm getting ready to draw the next frame on the screen. So step 1 is going to be clear the canvas. Step 2 is the doozy. Step 2 is, I mean, the biggest step, I think, of all of them. Step 2 is going to probably be the step that requires the most code to pull off. It's update positions of everything and redraw. Oops, forgot a letter there. So in this case, I said of everything. Well, in this simple example, we only have one thing. That may change a little bit later, but right now we just have one thing that we need to update. The position of, and then we'll redraw it. So you can see that this part takes care of updating the position. Every time I draw a new frame, I'm going to update the X position of the ball by scooching it over a little bit, right? And then if I hit the edge of the screen, then it's going to move me back to the left-hand side of the screen. That's what that if statement is doing. You can see that action. As it hits the right side of the screen and moves back to the left, this is what's doing that, right? And you can see that when the ball is being drawn, it uses that variable. So every time through the loop, this variable is just going to be slightly bigger, unless it hits the wall, in which case it gets reset back to 0, and then continues to climb. So this is how we get the ball to move, right? Clear it, move it a little bit, draw it again. Clear it, move it a little bit, draw it again. But step 3 is down here. Step 3, we have to pause. We have to pause to make the animation smooth. So this pause is given a number. This number is in milliseconds. So I'm saying how long do I want to wait in between each frame? So if I'm only waiting 10 milliseconds, that's actually going to get me 100 frames per second. That's a lot. That's probably more than we actually need, and actually probably a reason why it's kind of flickery. I would encourage you to kind of experiment around with this number a little bit. What if we change it to 20 milliseconds? What if we just slow the frame rate down a little bit? Still a little choppy, huh? What about 50 milliseconds? So that would be, what would it be, 50? Would that be 20 frames per second? Okay, less choppy, that's good. But you can see it's moving a little bit slower as well because I'm not drawing as many frames. I'm not updating the position of the ball as quickly because I'm waiting more time in between each frame. So this frame rate actually has a huge effect on the animation. It is something that is hard to get right without a little bit of trial and error in my personal experience. So if you find yourself experimenting and finding numbers that work a little bit differently on your computer than mine, I'd say that's pretty normal, right? But just to recap, those are the three parts. So anytime I want to do animations, I'm going to have a loop. My animations have to take place within a loop. Within that loop, I'm going to do three things. I'm going to clear the canvas first. I'm going to update the positions of everything. This is the actual animation part. I'm going to move everything a little bit. I'm going to redraw it on the screen. And then I'm going to pause for a second so that our brains have time to receive the visual signal from the screen and perceive the animation. Are there any questions about anything that I've talked about so far? Because I'm about to modify this and play around with it and tweak it and kind of go above and beyond, but I want to make sure everybody's on the same page with me first before I do that. Any questions? Anything I can address so far? It's a good thing. I hope that means you kind of looked at this and were at least a little familiar with some of the stuff that I said before you came today. Let's play around with this a little bit. I actually want to make a game today. I'm going to make a game right here in front of your very eyes today, and you're welcome to follow along with me, and you can tweak your game and make it to your own heart's content. What I want to do first, though, is kind of make this a little bit more interesting. Right now, it's just moving in a straight line across the screen, right? And then once it gets to the other side of the screen, it's going back. Well, maybe instead of that, which is a little bit unnatural, right, to see the ball kind of teleport, maybe I would rather have it bounce. Maybe I'd rather have the ball bounce backwards. In order to do that, I think I need to tweak this code a little bit, right? So I see it right now. I have a variable for the ball's x position. What would be true if I wanted the ball to bounce? It's moving to the right, hits the wall, bounces back to the left. What am I talking about? What's the term that I'm talking about for moving to the right, moving to the left? If this was physics class, we would call that, starts with a V, velocity, right? We would call that the velocity of the ball. If this was a physics class. I know it's not a physics class, although kind of, sort of, a little bit physics class maybe. The velocity of the ball needs to change. So if I'm moving to the right and then I hit the wall, I need to switch the velocity and move me back to the left. The velocity of the ball right now is right here. I want to change it, though. I want to be able to change the velocity. So in order for me to do that effectively, I think I need to turn this into a variable. And in fact, I would argue that this is better as a variable anyway. When I look at this statement, it's a little unclear to me, as it maybe was to you, what this number represents. But if I can apply a name to that, it'll be a lot more clear what that number represents. So let me show you what I mean. If I come up here and I say double ball x velocity is equal to 0.005, and then I switch the statement down here, not to say 0.005, but ball x velocity, this now looks a lot more understandable, right? I'm updating the position of the ball based on its velocity in the x direction. And so then we just need to figure out, we need to tweak this a little bit. We need to figure out what to do if it bounces. Right now, it's going too far to the right. I'm just repositioning the x coordinate, but we just talked about how I want to switch the velocity instead. So if I was moving to the right, I need to move to the left, and I'm not going to worry about friction or any of that stuff. This isn't physics class. We'll keep it purely elastic, I believe is what it would be called. It's been a while since I've taken physics, but we'll just conserve all of our velocity. We just need to switch the direction, right? If I was going to the right, I need to switch it back and move to the left. So to say that, I could say something like ball x velocity equals negative ball x velocity. Just flip the sign on the ball, on the velocity of the ball. Positive velocity is moving to the right, negative velocity is moving to the left. So all I did was introduce this new variable and then make a few changes down here to manipulate the velocity. Let's see what happens. See what happens. Excuse me, gotta wait for this ball to get all the way. I might increase the velocity a little bit. It's moving a little too slow for me. I'm gonna put it up to 0.01 for starters. Now let's try again. All right, now it's chugging along a little bit faster. I like it. It hits the wall. Boom. All right, cool. Hey, there it goes. And then we're gonna get all the way back to the other side and whoops. Okay. Where'd my ball go? It's over there, right? It's flying out the wall into the next classroom right now. And we'll eventually, you know, get all the way over to Graham Chapel and the Duck and then across the state of Missouri into Kansas, right? Like, it's going. There's nothing stopping it, right? The ball is heading in the direction so some of you maybe already figured out what I did wrong here. I'm checking to see if it went too far to the right, but I don't have anything to check to see if it moved too far to the left. Fortunately, I think I can actually, so you might want to copy paste this if statement. I don't think we need to do that, right? I don't think we need to do that. Consider what happens if I get to the left. I need to bounce it back to the right. I'm still flipping the sign. So I can reuse this if statement. I'd probably say it like this. Let me update these comments to more accurately describe what's happening. If the x coordinate of the ball is greater than 1, it's off the right edge. If the x coordinate of the ball is less than 0, it's off the left edge. In either case, I'm just going to flip the velocity and make it bounce back, go the opposite direction of wherever it was going. Let's try it. Let's run it again now and see if we have contained the ball within the screen, hopefully. All right, cool. Still a little flickery. I'm not sure that I'm a huge fan of the flickeriness of it, but it's hard to get that right. It's hard to get that right. Still flickering a little bit. Anyway, okay. Everybody with me so far? Any questions about what I've done? I'm gonna make some more changes next. And you maybe have guessed where I'm gonna go. I'm only moving in the x direction so far, but I have this whole y dimension that I could be moving around in as well, right? So why don't we have the ball move in the y direction too? What am I gonna have to do if I want the ball to move in the y direction as well as the x direction? What's gonna have to happen? Yeah. I need a y velocity, and I probably also need to track the y position as well, right? So let's make some more variables. Double ball y is equal to, so its original y position is actually right here, or that's what it has been. We can change that, of course, if we want to start somewhere else, but its y position that we've been using is 0.5, and then we can give it a velocity as well. And then we also need to go down here and update the position in the y direction, which involves doing everything that we did in the x direction as well. So ball y is equal to ball y plus ball y velocity. And then be careful, right here when I draw the point, it's got this hard-coded 0.5 in there right now, but that's not what we're using to track the y position of the ball, right? It should be ball y. Okay, let's try this and see where we're at. There it goes. Oh, there it goes. Okay, so we have the same position with the top and the bottom, the same problem with the top and the bottom that we did with the sides, right? If the ball goes off the top, I need to send it back. Well, that's this again. That's this if statement again. We just need to do it for the top and the bottom. So if the ball y is greater than 1 or the ball y is less than 0, then instead of flipping the x velocity, I'll flip the y velocity. All right, let's give this a try and see if we've successfully contained. Yeah, there we go. It's working. Now with the numbers I've chosen, it's tracing the same path, right? It's just doing a diamond basically around the screen. But if you want to tweak that, you definitely can. One of the things that I like to consider doing, especially with the velocities, what if I wanted to pick a random velocity? Could I do that? Sure, why not? I know this was, something we talked about prior to the exam. Maybe it's too soon to bring that up, but if I take a random value and multiply it by 0.01, now I'm randomly setting the velocity to somewhere between 0 and 0.01 in both the x and the y direction. That should give me a little bit more variation in the movement. So now you can see I got a different angle, right? Got a different trajectory for the ball moving around the screen. Everybody with me? So this isn't a game yet. I promised you I wanted to make a game. Games require interaction with the person playing the game. I mean, presumably it's a person. Computers also are getting very good at playing games, as some of you probably know. But here we're going to focus on human players. That means we need to get input from them in some form. So those of you who are big gamers know that's probably either via controller, which I'm not going to touch right now, or keyboard and mouse, which we've actually already kind of done the keyboard a little bit, right, with the scanner. However, scanner doesn't really work so well for what I want to do. I want it to update in real time. Scanner kind of takes a little bit of time for us to process. But the good news is that the standard draw library has ways to interact with the keyboard as well. And so if I take a look at what some of these methods do, then maybe I can try to think of a way to incorporate them into my game. I think what I want to do is we have our ball currently moving around the screen. I'm going to put another one on there that I can control, that I can move around the screen. And then we'll just play a game of dodgeball, right? Basically, I'm trying to dodge the one that's moving around the screen. But first, let's get a ball up and running that we can move using the keyboard. In order to do that, we're going to use, where are they? Where are the methods that did I pass? Oh no, they're right here. We're going to use these methods here. In fact, I think this might be a good one to take a look at. Is key pressed int key code? So basically, we're asking a question. I can ask if any key is pressed on the keyboard. We just need to know what the key code is for a certain key. So I'll just ask, is this key pressed? Is this key pressed? Is this key pressed? I'm going to use the WASD keys on my keyboard. That's a pretty standard way of controlling. W for up, S for down, A for left, D for right. So how do we do that? How do I incorporate that into my game? Let's get started with that. I'm going to make another ball. So I need to have this information for that ball as well. And that ball is going to represent me, the player of the game. So let's make some variables for player X. That's my X coordinate. Oops. And just for simplicity, I'm going to make my starting coordinates at the middle of the screen, right in the middle. We also need a velocity. I would argue that since the velocity is based on me pushing the buttons, right, it should probably be the same in both the X and the Y directions. Could simplify that by just calling it player speed is equal to 0.01. We may need to tweak the speed a little bit later, depending on how it actually works when we try it out, to make it move a little faster or slower, depending on the difficulty of the game and our personal preferences. But I actually think this is enough to kind of get us started. We now need to revisit specifically step 2. update the positions of everything and redraw. So right now, I'm not updating my position or drawing the position of the player. First, let's tackle the easy one, which is drawing the position of the player. We can do standard draw dot point, and this time we'll just put in player X and player Y. But that doesn't account for any motion. That doesn't account for moving the ball around. Although we should be able to see it if I just run it right now. There's me, right? That's what I want to be the player. But if I hit the keys, nothing happens. The other ball's moving around. But okay. So how do I make it so that I can move around when I start pushing keys? Let's try that next. I'm still in the middle of this loop. I'm still in step 2, right? So before I draw, I want to update the position of the player X and player Y based on what keys are pressed. So I'm going to ask a question. I'm going to ask, is the W key pressed? That's the first question I want to ask. If standard draw dot is key pressed, and now we need to put a key code in here. This is maybe one of the more complicated parts of using this method. It takes a key event, and so they're actually linking us to another API that includes, it's basically just a list of all the different keys on the keyboard. So you can see that this one literally means the B key, right? I'm looking for the W key. I said I was going to start with the W key, which is just going to be VK_W. So the way I would say that is key event dot VK_W. I think, did I do it wrong? Oh, and now it's upset because I need to import key event. So that's what this is about. We can solve that by just clicking the top option that's selected here, import key event. There we go. If, so this means I'm moving up. I'm pushing the W key, so I'm moving up. So I need to adjust the Y coordinate of the player. And because I'm going up, that means I'm going to add, right? I'm going to add to that coordinate. Oops. And I'll just put player speed here. Okay. I know we have other keys to go. I've only done W. I also want to do A, S, and D to cover the other 3 directions, but let's just try it. Let's see if I can at least move up. There we go. Oh, and off the top of the screen too. Uh-oh. So I have boundaries checking to make sure this stays in, but I don't have any boundaries checking to make sure that I stay in the screen. Uh-oh. We may come back and fix that a little bit later, but I want to finish doing the arrow keys first. So let's add in another one for down. I'm just going to copy this chunk and change the key to be the S key instead, since S is what I'm going to use to go down. And instead of adding the player speed to the Y coordinate, we will subtract the player speed from the Y coordinate. Now that should give us down. But I still can't go left or right. Not going to happen. Okay, but I can go down and up. And with a couple of other if statements here, I should also be able to do left and right. So left would be the A key, right would be the D key. And then I just need, since I'm moving left and right, I'll just switch all of these to say player X. And this one needs to be a plus instead of a minus. If you want to comment all of these here, you can. Left, right. And now we have code that will hopefully let me move around the screen, the entire screen, in any direction that I want. Let's take it for a spin. So it won't let me do 2 directions at once. That's somewhat of a limitation, but otherwise it seems to be working pretty well. I hope you are also successful in getting this going. I'll leave this code up here on the screen for a second in case you are trying to follow along with me. And also pause for a moment, see if anybody has any questions. I'm not done yet. Still isn't quite a game. Did you have a question?
So clear will clear the whole screen, right?
Correct.
Is there a way to clear part of the screen?
There's not, no. Yeah. If you want to clear just part of the screen, the option would be to clear the whole screen and then redraw, the part that you want to keep, basically. But really, in practice, you're redrawing the whole screen every time. Yep. Think about it. I mean, it's not unlike traditional animation. If you're familiar with, like the old school Disney cartoons, they were literally drawing the same thing over and over and over again with, Mickey Mouse just moved slightly on each picture. They had to redraw the whole thing every time and then flip it, to make it animate. Any other questions before we move on to some more functionality here? Okay. What I would like to do next is give us an objective. So right now, I see this ball moving around the screen, and I can move. So I want to dodge it, right? Or maybe a better way of saying is I want to know when I touch it. So when I touch it, I want that to do something, right? Probably affect me in some way, right? I touch the ball, probably want to restart over again back in the middle of the screen, perhaps, right? Or something like that. But first, I have to be able to detect that. How do I detect whether I hit this other ball or not? That's going to require some geometry. In fact, it's going to require the good old distance formula, right? In fact, I don't have the distance formula memorized, even though I've used it a million times myself, so I need to refresh my memory. We're doing some math here where one of the x-coordinates represents the ball that's moving and the other one represents me as the player. So if I take the distance between those two and it is less than the radius, or twice the radius, I guess would be more accurate, then I know they're touching. I know those balls are touching. So let's see if we can't put that in the code. All right, so the distance between. We need to do the distance formula. First thing is square root. We can do square roots. That's definitely a thing we can do. I don't know if I've asked you to do it prior to today, but if you were, a little unsure, hopefully you said, all right, Java square roots into Google, and here we go. Math square. Oh, we've seen math before. Is there one from Oracle, or is it all just tutorials? Oh, well, there is a math library that you've definitely used before, right? Math.random comes from there. But math does other stuff as well, and one of those things that it does for us is square roots. Eventually I'll find it. Oh, there's random. So there's math.random right there. But the one I need right now is square root. All right, so I'll say math.square root. And then within there, I need to take, where's my distance formula? I need to take x2 minus x sub 1 squared. Okay. I'll make, so the player x minus ball x. But I need to square that whole term. How do I square something? It's not that guy. That's what it is, maybe on your graphing calculators. It's not that guy. It's actually the math library again. There's a method in here called pow, short for power. Returns the value of the first argument raised to the power of the second argument. So if I want to square something, right, I put whatever I want to, the base here, and this is the exponent, right? So, all right, what I really needed to say is math.pow, not power, pow, and then take that whole thing squared. So that takes care of my x coordinate. I have to do the same thing for the y coordinate, which I'll haste over here and switch the x's to y's. This is kind of a long line of code. I'm a little uncomfortable with how long this line of code has gotten. I'm almost at the point where I want to break it up into smaller chunks, but I'm done. I've implemented the distance formula. So now we just have to check and see, are we touching or not? Have we collided? If the distance between is what? Less than. What's the radius that we're using? It's actually given right here. Set pen radius. It's given as 0.05. So 0.01 maybe would be a place to start. This means collision. There's a collision here. What do we want to happen if there's a collision? I'll just reset my position to be the starting point. So if I collide with the ball as it's moving around the screen, I'll reset my position back to the center. Eventually we might want to do a little bit more than that, but for now, let's try this and see if it works. I'm going to run this code. I'm able to move around the screen, and then if I get up here, chase down this ball. Oh, yeah, it worked. It does seem to be not quite so... You can see that it's a bit bigger than I would anticipate. I don't know if my math is off. I know trial and error is not really the best way to do what I'm doing right now, but for the sake of time and just to kind of try and get this look a little nicer, I'm going to see if the tweaking... Oh, this... Yeah, oh yeah, that works a lot better. I'm not sure why that number works better than 0.01, but it does, and I mean, you can tell the collision seems to be working pretty good, right? Not perfect. It's hard to get it to be exactly perfect, but we're doing pretty good. All right. Let's keep going. I would say that we're almost able to call this a game, but we need some way of tracking points or there. You know, how do I know how well I'm doing? I think what I want to do is incorporate time into the mix. So I want to keep track of a score, and then every second that I go without colliding with the ball, I'm going to give myself a point. Right? So as long as I dodge successfully, my score will keep going up, 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 up. And then maybe as soon as I collide, that resets the game. Right? Puts me back in the middle, sets my score to be 0, and I have to start all over again. Okay, we can do that. But in order to do that, we have to talk about time. And this actually wasn't in the prep work, so this is something that I would not have expected you to see before. However, it's not too tricky to understand, and also it will be relevant on this week's homework assignment as well that's coming up. Let's talk about time and how we can incorporate time into the mix. There is a method that I want to talk to you about called system.currentTime_millis. This tells us the time, what time it is right now, or whenever the program runs it, right? But it gives us that time not as, 1:44 p.m., but as the number of milliseconds that have elapsed since January 1st of 1970, which might seem like a very weird way of keeping track of time, but it works, right? If I know how many milliseconds have elapsed since January 1, 1970, I can base everything off of that if I want to, right? Somewhat arbitrary, yes. There are some problems with it, yes, that we're not going to get into, but that's how it works. So this is going to give me back a very large number that represents the time, what time it is at this moment. And I want to know then what time is it a second later, or maybe a more accurate way of asking that is I want to know if a second has elapsed, right? I want to know if a second has elapsed since the last time I got a point. So what I'm going to do is I'm going to save this into a variable. And now, int is close to what we need here. But remember, the ints only go up to 2 billion something. And this number is larger than that. This number is going to be larger than 2 billion and something. It's going to be very large. So we're going to use a type that is similar to an int. I can't remember if I've mentioned this. I feel like maybe I did mention this type in class before. It's called the long. Longs are ints. They're just bigger. They can just be bigger. They can have bigger numbers. But otherwise, they act just the same as ints. I'll call this the score timer. Notice I'm outside of the loop right now. Outside of the loop right now, right? Keeping track of the score timer. So when the game first starts, it's going to record what time the game started. That's what this line is doing. When I click go, this line of code is going to write down when the game started. Yeah, question?
What's the point of having both int and long as two different variable types?
What's the point of having both int and long as two different variable types? I love that question. So consider, because long can hold numbers that are bigger than 2 billion, it takes up more space. So a long is 8 bytes of data on my computer, whereas an int is only 4 bytes of data on my computer. So if I can fit stuff in ints, which most things can be, right, they're going to take up less space, which for our purposes really doesn't matter. But in a big program, you care about stuff like that. It matters. Yeah, great question. So yeah, the question now is, has it been 1 second past, whatever this is? So inside of my loop now, I'm going to do a timer check. It doesn't really, I guess, matter where in the loop this goes so much, but I'm going to do it, where do I want to put this code that I'm about to do? I'll do it after I'll do it before I draw, right before I draw, because I need to draw the score on the screen as well, right? So I also need to draw what my current score is so I know what my score is. So, all right, we're going to do a check to see if a second has elapsed. I'm going to say double now is equal to system.currentTime millis. So think about what this means, right? I asked what the time is up here. All this stuff happens. This takes time. It takes time for the computer to do this. Not very much. Computers are very fast. Very, very fast. But down here, it's going to get down here. This time is going to be after this time. Guaranteed, right? Guaranteed. But is it a second after? I don't know. I don't know if it's a second after. But we can ask if now is greater than the score timer plus 1,000, because there are 1,000 milliseconds in a second, right? So if the time that I recorded now is 1,000, at least 1,000 more than whatever time I remembered it being, that means that 1 second has elapsed. So if 1 second has elapsed, what do I want to happen? I want the score to go up. Well, I haven't tracked the score yet. Let's do that. Let's make a variable for my score. Int score equals 0. Starts out at 0. But if a second has elapsed, then I'll say score plus plus. But wait a second. The baseline now that I need to compare against is 1 second after whatever it is right now. Or in other words, right, this timer needs to be reset. I don't want it to remain 1 second ago. Do you understand? Because I've already covered that second. I now need to update this timer so that I can catch it again 1 second from now. Let me show you. This is conceptually tricky to understand, but easy to type out in code. This should be a long, not a double. Why did I make that a double? That was just my brain not connecting the dots properly. I'm sorry about that. So I've detected that it's been 1 second, so now I'm going to say, all right, score timer needs to be whatever time it is now, so that I can check the next second, and the one after that, and the one after that. Please let me know if I lost you, if you have any questions about this. Yes? Absolutely, yeah, I'd be happy to. I'm not sure if there's a particular piece you needed to see. The score? Okay, so score starts at 0, and notice this is outside the loop. So before the game starts, score is 0. If a second has elapsed, then I want my score to go up. So the longer I go without colliding with the ball, the higher my score will be. But actually, now that you bring that up, right, consider that if I collide, what do I want to happen? I want score to go back to 0, right, to reset. That's an important part as well. So thanks for bringing that to my attention. The last thing that we need to do is draw the score on the screen. So how do we do that? Well, we have a library called Standard Draw. I want to put some text on the screen that says score and then a number afterwards. So let's go back to the Standard Draw API and see if we can't figure out, did I close that tab? Shoot, I already closed out the tab with Standard Draw, my bad. Let's go back to Standard Draw here and see if there's something that allows me to put the score on the screen. I already know there is. It's called, where is it? Control F is your friend. I want to put text on the screen. So, oh, here we go. I scrolled past it. I missed it before. Text. There's a whole bunch of stuff about text. Okay. So this one here says $x, $y. So the center coordinate of the text, the x, y, and then what I want the actual text to say. So if I want to use that to put the score on the screen, I would say standard draw dot text. Where do I want the score to be displayed? I'm going to try and display it kind of at the bottom here. So the x coordinate would be about 0.5. The y coordinate, I don't want to put 0 in because I think that would hang off the bottom. So I'd probably put in like 0.1 or something to make it a little bit above. And then as far as what I want the actual text itself to say, I'm going to say score, and then I'll just concatenate my score variable on the end. Let's take it for a spin. Oh, okay. Hey, yeah, there's my score. It's counting up 1 as every second elapses. I don't know if it's exactly a second, but it seems close enough, right, for my purposes. And now the question is, okay, what happens when I run into this thing? Boop. And oh, my score reset, right? It went back. You can try it again if you need to. Boop. Back to 0, right? Back to 0 it goes. And actually, I think there are probably some, there definitely are some issues with this still. I didn't fix the part where I can go off the edge of the screen yet, but that's fixable, right? That's definitely a fixable problem. There's a little bit of a problem with how the score resets, depending on how or when you hit it. It's possible to like start it at right before, it ticks up and it doesn't take a full second. I mean, it's a small issue to contend with, but yeah, we have a game. This is the game that I was hoping to build. Does anybody have any questions for me on this? I'm not done yet. I have more that I want to talk about, but I want to pause and see if anybody has any questions for me. Yes?
Could you explain more about if now is greater
The timing?
Yeah.
Sure.
Timing.
Let me do you one better. And, well, actually, I was going to say I was going to run it through the debugger, but there's a problem with the debugger, which is that it pauses the execution, which makes the timer run. So that's a little bit tricky. Maybe what I can do instead is use a print statement, right? I'll print out the score timer, and then I'll print out what time it is now. And it's only doing this once per second. So you can see that once per second, I get 2 numbers printed out. But you'll notice that it's actually printing out the same number twice. So let me stop execution now and explain what these numbers actually represent. This is the time that was first recorded right here. So that is the time as it was when I started the program. every time I go through this loop, I ask what time it is now, I ask what time it is now, I ask what time it is now. Eventually, enough time will have passed to where the current time is more than 1,000 milliseconds later than this time. And you can see that here, right? It actually went a little bit farther than 1,000. That's okay. That's okay. So that tells me what? That I need to increment my score by 1, and I need to get ready to track the next second. So how do I track 1 second from now? My score timer is now going to be this number, right? And I now need to know when it's 1 second after this number. So that's what this line is doing. It's saying take whatever time it is right now. That is our new baseline. That is our new base timer that we are checking to see if it's 1 second after. And so now I'm waiting to see what's 1 second after this. And okay, here I finally reached the point where it's 1 second later. One point I want to make, how many trips through the loop? How many trips through this loop did it take to actually get through 1 second? I don't know, but it was a lot more than one. It could be hundreds, right? The computer's fast. The computer is doing all of this. A single line of code takes a fraction of a second, right? A very small fraction of a second. The computer can do everything that is in this loop in under a second, easily. So, how many trips is it taking before it's finally detected that a second has passed? A lot of them. We're just constantly saying, what time is it? What time is it? Is it a second later? Is it a second later? Is it a second later? Oh, it is a second later? All right, score goes up by 1. And now I'm going to wait until it's been a second later from the time right now. And then we'll repeat that process over again. Did that explanation help? Yeah?
This is all happening within the while loop.
It is, yeah. This is within the while loop. Yeah, you'll notice that other than initializing stuff, this is all just initialization. Everything else happens in the while loop.
But the score timer exists outside of the while loop.
It does. I have to set the initial time of the score timer. Yeah, when the program first starts. Yeah, of course. Thanks for asking the question. Are there any other questions I can address before I move on? So I think this is a pretty cool game, but I mean, it could be made a lot cooler. I don't know that I have time to add a bunch more stuff onto it, but I do want to talk about at least a couple of things and maybe give you some ideas and encourage you to take this and run with it and do some other stuff, explore more with it, play around with it, add stuff to it, make it more fun. One thing that I want to talk to you about, I mean, this velocity is pretty slow, right? It's not very hard right now. So definitely, if I wanted to make this more of a challenge, I want to bump this velocity up a bit. Let's see. Oh, wow. And now it's definitely a bit more challenging, although still not too bad, right? For me to dodge. I think what would be even better, perhaps, than bumping that velocity up for increasing the difficulty would be, right now there's just one moving around the screen. Could I have more? Could I put a few different ones moving around the screen that I have to dodge all at the same time? Oh yeah, I definitely could. How would I do that? How would I make it so there's not just one ball moving around that I have to dodge, but there's a whole bunch of them? Anybody have any ideas of what I might need to do to pull that off? It's one of your favorite things that starts with an A and was on the exam just last week. I can use arrays. If I want more than one thing, that's a collection, right? A collection of things. So if I want 3 balls moving around the screen, right, I need 3 x positions, 3 y positions, 3 x velocities, 3 y velocities. I can do that. That's all very doable. So, instead of just having one variable for x, there's a couple ways you can think about it. I can make one array for each of these, right? One for x position, one for y position, one for x velocity, one for y velocity. That's not a bad idea. In fact, maybe I'll do that real quick. Double ball x equals new double, and this time I'll do, we can just do 3 just to keep it simple. But consider we now need to set up all of these values, right? We need to say what the initial starting x position is for all of them. So It's going to take more work up front to set all this stuff up, but we can definitely do it. Let me see if I can crank this out real quick. X velocity, and then finally ball Y velocity. Okay, now instead of just saying I want the position to be 0, well, I need to go through, I need to write a loop. I need to go through and create these values for each one. So I'm going to say I is equal 0, I is less than 3, I plus plus. I'll say that I want the ball X at position I to be, I like using math.random because think about math.random, it's between 0 and 1, and what's my X coordinate? It's between 0 and 1. So I think math.random works really well here. Same for the Y coordinate. Oops. And then for the velocities, we want to be careful. A velocity of 1 would be like, way too large, taken off. So we need to, that's why it's important to multiply for the velocities, but we can actually do something like this for our initial velocities. Do the same in the Y direction. Okay. I have successfully taken all 4 of those values, and instead of just having them as one variable, they're all arrays now. And I was actually very careful to name them exactly the same thing because that kind of helps me down here. Now you can see everybody's mad at me, but why are they mad at me? They're mad at me because this is an array, and if I want to pull information out of an array, I have to provide an index. So really, what do I need to do? I need to take all of this stuff and wrap it in a loop. So basically, all this stuff right here needs to be wrapped into yet another loop. Let me Control-A, Control-I to fix that indentation. And now, to fix the problems, we just need to add bracket I to all of these variables to reflect the fact that we are dealing with arrays. And as we do so, you'll see Eclipse gets happier with me as time goes on. Almost done. Maybe it was a faster way I could have done this, but it's over now. The only other issue is going to be oh, yeah, this needs to go in the loop too. Do you see that? This chunk also needs to go in that loop, and actually I would say that this is also going to need to go in that loop because I'm not drawing one ball anymore, I'm drawing multiple. So let me move this code up to the loop. And tack on the indices. And then finally, I will grab the draw statement down here. And move that up as well. Okay, so let me take a second and just discuss what I did. I know that I changed a lot of stuff, but really what I changed, I didn't change the flow of the code. I didn't change the logic of the code at all. I just changed it to reflect the fact that now I don't want just one set of balls to dodge. I want multiple. I have an array of them. So all of the references to the singular x and y coordinates before had to be updated to reflect that I now have an array of those things, and then this loop, the first time through the loop, it's going to update the position of the first ball and check to see if it, collides, check to see if it collides with the player, and then draw it. The next time through the loop, it's going to check the second ball and see if it hits the wall, see if it collides with the player, and then draw it on the screen, and so on and so forth. Let's try it out. Oh my gosh, the velocity is going way too fast. It does work though. Why is the velocity going so dang fast? Let's tone that down a bit. Holy moly. Why did that velocity get so fast? I'm a little confused about that, to be honest with you. But this is a bit more reasonable. Here we go. Ah! Score's going up. Oh, shoot, it got me. It kind of is a little annoying that they're all the same color, right? Oh, it reset me, but it didn't reset my position? I'm a little bit confused about that. Still some bugs. I'm not surprised that I made some mistakes. But, the sky's the limit now, and instead of having 3, put 10 in. Why not? Why not? I also would like to maybe switch the colors. Here I'll make sure I'll set the pen color to be red. But when I draw myself, when I draw the player, before the player gets drawn, I'll set the color to be black, just so that I can more easily distinguish between the two. Oh no, why are you down there? I think I need to change this. Say 10. Alright. Oh my goodness. Ah! Whoa! It's working. It's kind of working. It's also kind of not, to be honest with you. The score is resetting to 0, but the position isn't. Did I miscopy it or something? I don't know what happened there. Oh yeah, I forgot to update the position here. I guess I just forgot to copy that part. I'm not sure I understand why I forgot to copy that part. But anyway, yeah. Okay. Sorry, I can mess around with this all day, like quite literally. I'm having a blast right now. I hope you're having fun too. But yeah, take it. There we go. Yeah, that's a little better. I don't like the flickering, but I'm not going to fix that right now. We've spent enough time dealing with it. Please take this and run with it. It's a lot of fun. There's more you can do with it. Actually, one thing that I had on my list, if I had time, which I don't have time to do, but one thing that I wanted to do is, okay, the score goes up once every second. Maybe you start with 3 balls on the screen, and then after 10 seconds, if you haven't gotten hit, it goes up to 4. And then after 10 more seconds, it adds another one. And then after 10 more seconds, it adds another one. That's definitely doable. You can totally make that happen. But I'm not going to have the time to do that right now. We do have a little bit of time left, and I want to chat with you about one more very important thing before you leave. It relates very much to the next homework assignment that's going to be due next week. We're having you make a little game, and that may not be terribly surprising. We're going to have you do Cookie Clicker, which I don't know how many of you are familiar with Cookie Clicker. I love idle games. I play so many of them. I play Cookie Clicker. I love it. It's great. It's a classic, in my opinion. You're not going to be recreating every single thing that Cookie Clicker does. We're going to keep it very, 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 very basic. But I also want to chat with you about our good friend AI, because on this assignment we're almost I would say we are encouraging you to consider using ChatGPT a little bit if you get stuck. ChatGPT or other AI tools are very good tools, and you're already at the point where it's worthwhile talking about them. I know I gave a big speech at the beginning about how you can over-rely on them. I think some of you maybe perhaps found that out a little bit the hard way on the first exam. But, for those of us that are cruising right along and understanding the stuff that's happening, I think it's useful to understand what ChatGPT can do for you and just how good it actually is. The first thing, that you need to do for Cookie Clicker is draw a cookie on the screen, like quite literally draw a chocolate chip cookie on the screen, right? And you might be thinking, oh, that sounds pretty tedious to do. Like I actually have to pick the right colors and draw the circle and decide where to place chocolate chips and draw them too. And it's like, well, yeah, I mean, yes, you do need those things. That is part of what we're asking you for. But also keep in mind that AI is good at stuff. I don't want you to avoid using AI. I just want you to use it in a smart way. So, let's take a peek at maybe some good ways of using ChatGPT. Bad ways of using ChatGPT would be copy-pasting the entire assignment spec in here, right? That would be a not Professor Shook approved way of using ChatGPT. What might be a more Professor Shook way of using ChatGPT? Using standard draw in Java. Draw a chocolate chip cookie. And here we go. Below is a sample of code that demonstrates how to do this. And oh, hey, look, we didn't talk about all of these things, but we did talk about some of them. We've seen some of this stuff, right? And okay, here's an example of ChatGPT doing stuff that. So ChatGPT is smart, right? ChatGPT knows a lot. ChatGPT knows more about coding than I do because it's a computer, right? It has access to more information than I could ever possibly conceive of in my brain. And so you might look at this and be like, huh? What's this? Professor Shook hasn't told me about this yet. Well, that's okay. Make ChatGPT talk to you on your level. Everything that we've done has been within the main, within this main. So, if you don't like what it says or you're confused, say put everything in main. And then voila, it'll rewrite it for you. Take out the stuff that we haven't talked about yet, because actually, little side tangent note, while we haven't talked about this yet, this is the topic for next week. This is called a method, so we are going to talk about these very soon. This is coming up very soon, but we haven't talked about them yet. So if you want to keep ChatGPT on your level, meet you where you're at right now, tell it, hey, I want to keep everything in main, and then look, we've got what's hopefully going to be a beautiful chocolate chip cookie. I want to test it out and see how well. I know I'm deleting my beautiful game, but I'll Control Z and put it back just a little bit later. Let's see. Oh, did I forgot a bracket or something, didn't I? Oh, I have main twice. That's not good. I probably have too many brackets. Hey, yeah. Sure. It's a chocolate chip cookie. Sure. Could I have sat down and done all that myself? Absolutely. Do I personally enjoy doing stuff like that? No, I do not. No, I do not. I don't have any problems asking ChatGPT to do it, but you gotta understand it. I mean, I can't say it enough. I've tried to, make that point over and over again. Tools are great. I think it's awesome that we have lots of code at our fingertips in a way that we never have before. But you gotta understand this stuff. ChatGPT is wrong sometimes. ChatGPT misinterprets things sometimes, does things that you don't expect sometimes. You have to know enough to look at what ChatGPT is telling you and know whether it's legit or not, know whether it's what you need, what is being asked for, etc., etc. So please use it on assignment 4 if you want to. We're encouraging you to, but also make sure you know what it's telling you, right? Don't just blindly copy it in and call it a day. Make sure you understand what it's doing and try and do some of it for yourself too. Never hurts to practice. That's it. That's all I got for you. Thanks. Hope it was a good day. I'll see you in class on Wednesday. Have a good week, everybody.